Hello, everyone. Welcome back. Thank you for joining us in our lesson 5 under electrostatics, and we are now looking at electric field. We are now looking at electric field, and we are now looking at electric field. And then I'm going to show you how to calculate electric field strength at a point, and I'm going to do one example for you. Now, let me just take you back a little bit. In our previous lesson, we were looking at net electrostatic force, where we were looking at three charges which are in a straight line and three charges whereby another charge is at an angle. Right. Now we are moving on to electric field, and now we are supposed to know how to calculate electric field strength at a point around a charge. And then from there also we must learn how to calculate net electric field. Is that okay? So let's quickly start our lesson, and I'm going to give you definition for electric field. I'm not going to give you too much stuff here because it's very straightforward. So what is electric field? I'm going to write the definition right away. Now, electric field is a region. Now I'm going to underline the term region. Electric field is a region of space, right, in which an electric charge in which an electric charge will experience a force. Now, what are we saying here? We are saying if you take a charge, a point charge, remember we are talking about static charges, charges which are not moving. That's why we call them point charges. You put it somewhere and then you take another test charge, just a small charge, and you put it close by. That test charge will experience a force. Why does it experience a force? Because it is within the electric field of another charge. So that test charge is either going to be attracted or it is going to be repelled. So we are going to use a test charge, and for the sake of our calculations, we are going to use a positive test charge. So if you take a positive charge and put it somewhere, and you take a small test charge which is positive, you put it around that particular charge, it is going to experience a force. So if the original or the main charge is positive, there's going to be repulsion. So it means the test charge is going to be pushed away. So the direction of the electric field will be the direction that is taken by the test charge. So it is going to be pushed away. But if the main charge was negative, then it means the test charge is going to be what? To be attracted. It's going to move towards the main charge. So in that case, the direction of the electric field, it will be towards the main charge, right? It is very possible also for us to calculate the electric field strength at any given point within that jurisdiction or within that field around the main charge. We can calculate the magnitude of that force, and we call that electric field strength. And you are going to notice something here as we do our calculations, that distance still plays a very big role when it comes to electric field strength. The closer the test charge it is to the main charge, the greater the force that it is going to experience. So if you take that test charge, you push it away from the main charge, the force that it experiences, it will be decreasing up until it is beyond the electric field, and the test charge cannot experience a force anymore. Right. So let's write our bullet here. I want to put a bullet here which says the closer the test charge. And don't forget that we said this test charge is a positive test charge, right? So the closer the test charge and it is represented by small letter q. So the closer the test charge is to the charge q, the greater the force. The greater the force it will experience. So it is very correct for us to say distance and force experienced, they are inversely proportional. If the distance is greater, then the force is also minimum. But if the test charge is much, much closer to the main charge, then it is going to experience a greater force. Good. I want to write NB, which is a definition for electric field strength. Right. It says the magnitude, remember in science, magnitude means size. So the magnitude of the of the electric field, which is represented by capital letter E, at a point is there or is defined as the force per unit charge. Force per unit charge. So you underline force per unit charge. So from this definition, you can come up with a formula for calculating electric field strength, right? So we are saying the electric field or the magnitude of the electric field, which is represented by E, so you write your E there, is or can be defined as the force per unit charge, which means it is force over charge, right? So that is the first formula that we can use to calculate or to determine the electric field at any given point around a charge, right? So we need to identify these variables so that when we do our calculations, we will know what each variable represents. So E, that is the magnitude of the electric field, right? So E represents the magnitude, which is the size, the magnitude of the electric field, right? The magnitude of the electric field. And when you look at the formula, you can derive the units for electric field there. Force is measured in newtons and charge is measured in coulomb. So it means the unit for electric field there is Newton per coulomb, right? So F, what does F represent in that formula? It represents the Coulomb force, right? The Coulomb force exerted by a charge on a test charge, and our test charge is represented by small letter q, right? And as long as it's force, it is measured in newtons, right? Let me explain something here about the Coulomb force. So I'm saying if you are given a question where they give you the magnitude of the force that the charge is exerting, yeah, the force that the charge is exerting on the test charge, then we can use that particular formula. Is that okay? Then finally, our Q, it represents the charge or the test charge, right? Which is measured in coulomb, like that. So this is the first formula that we can use to calculate electric field. If you are given the Coulomb force and you are given the charge, then you can calculate the electric field. Then we have another formula which we can use as well to calculate the electric field strength, which says E is equals to the Coulomb's constant multiplied by charge over R squared. So it all depends with what you are given in a particular formula, in a particular question, and then you use that given data to determine the right formula to use, whereby E represent the electric field strength, the electric field strength. And this electric field strength it is still measured in Newton per Coulomb, right? And K represent our Coulomb's constant, right? To represent our Coulomb's constant, right? And then Q represent our charge, the one that is exerting a force, and it is measured in Coulomb. And then R, it represents the distance, right? The distance of the test charge, right? From the charge Q. How far is that test charge, or how far is that particular point from the charge, which is the main charge Q, and that distance is measured in meters. So it all depends with the question that you are given. The question determines the formula that you are going to use. So I'm going to quickly do an example for you, and then from there I can give you more work that you can practice on your own. But I want to say the nature of the question must guide you as to the formula that you are going to use. So I'm going to give you an example here on electric field strength, or on how to calculate the electric field strength. The question says calculate straight away, calculate the electric field, calculate the electric field strength, right? 20 centimeters from a plus 6 nanocoulomb charge. So we have got a charge here, which is plus 6 nanocoulomb, and we've got a point that is 20 centimeters away. We want to calculate the electric field strength at that particular point, and we are going to call that point X. So diagrammatically, you can represent the question, or the nature of the question, with a diagram. So I've got my charge, which is plus 6 nanocoulomb, and don't forget to convert nanocoulombs to coulomb. And then we've got that particular point X. So this X, it is within the electric field of charge 6 nanocoulomb. So we want to determine the magnitude of the electric field strength at point X, which is 20 centimeters away from the charge, right? So how do I respond to this question? I should go and read the question again and write my given data, because it is the given data which is going to determine the right formula to use. So the question says calculate the electric field strength, which means we are looking for E. So that's what we are looking for. But what are we given in the question? Distance is given, it's 20 centimeters. We convert that to meters. So it gives us 0.2 meters. And then charge is given, 6 nanocoulomb, we convert that to coulomb, and it gives us 6 times 10 to the power minus 9. This is coulomb. And then our K is a constant that we have been dealing with. We now know it even offhand. So this is clear. We are not given the force exerted on the test charge. So it means the right formula to use is the second formula. So I write my formula as it is. And remember, learners, that there is always a free mark for writing the correct formula as it is. So E is equals to, I make my substitution. K is represented by 9,0 times 10 to the power 9, I close. Q is equals to 6 times 10 to the power minus 9, I close. Over my distance is 0,2, and it's squared. Then E is equals to, now I need my calculator, and I need my calculator there, and my fraction there, and I open twice, and I've got 9,0 times 10 to the power 9, right? Then I close, I open, then I've got 6 times 10 to the power minus 9, right? And I close, and then I've got 0,2, I close, and that is squared. Don't forget to square, right? I'm getting 1,350. That is Newton per coulomb. That is the electric field strength at that particular point, which is 20 centimeter from the charge. So friends, learners, this is how we calculate electric field. We don't need the magnitude of the test charge. We just need the magnitude of the charge, the one that has got the electric field. And then we need the distance from the charge to the point that you want to determine its electric field strength. So the point, which is represented by x in our question, and the distance and the charge, we can be able to calculate the electric field strength. So it is very simple. And in our next presentation, we are going to look at net electric field, where we are given two charges and a point somewhere. Then we determine the net electric field. And I'm also going to give you electric field patterns. It is very important for us to know the electric field patterns of different charges. What is the electric field pattern of a positive charge? What is the electric field pattern of a negative charge? What is the electric field pattern of a positive charge and a positive charge, a negative charge and a negative charge? What is the electric field pattern of a negative and a positive? That is very important for us to know. So I'm going to do the next presentation, which is going to be our lesson 6. And please join us, join Edge Blush. We love you. You must take care. We meet again in our next presentation. Thank you.